Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are solving this pure math 1 which is P1 paper. This is of May-June 2025 variant 1-2. Remember, just a reminder, when we are talking about May-June 2025, I have already solved the 1-1 paper and then the 1-3 paper. Recently I have solved the fourth variant 1-5 and now it's time for the 1-2 paper. So all these four are available on my channel. So now let's get started with the first question. Now the first question you can see right away, it has to be about transformation of graph. Now keep in mind, let me circle few things so that it becomes very obvious. This is the x-axis, so I'm making it very visible, and similarly this is the y-axis. Now part of the graph is above the x-axis and the other graph is below the x-axis. Also focus on something like this. So let me focus that between these 2 points, this is 2 units, this is like 2 units. And then if I talk about the height, this is 1 unit, this is 2 units. So now there are few observations that you should make right away. The base is unchanged. The height, if I'm going from fx to gx, the height is doubled. And then something else would be taking place. So let's get started. So now the diagram shows fx and gx. Describe fully a sequence of transformations. So fully, that means give every detail, a sequence of two transformation which transform the graph of fx to the graph of gx. Make clear the order in which the transformation should be applied. So now let's look at the solution. What exactly have I done? I have marked few pointers. So now this red is becoming this red, this blue is becoming this blue, and so on. So just focus on the red. -2, 5 is becoming -2, -4. 0, 6, that is this point, is becoming 0, -2. Horizontally, there is no change. Vertically, it's double. That means it has to be a vertical stretch and then it has to be a translation. So -2, 5, this is the red thing. So let me just highlight this thing. So this is the red point. It's becoming this one and it's becoming this one. Now what do you see? And always double check with another point also. So -2, 5, if the stretch factor is 2, and let me highlight it, if the stretch factor is 2, the y coordinate is doubled. And then from a value of y coordinate 10, it's going to y coordinate -4. How many units are we going down? We are going down 14 units. So the translation vector is 0 and -14. We can also double check with this. 0, 6 is becoming 0, 12. And 12 minus 14 is coming out to be -2. So it's done and dusted. So question number 1 is all good. Question number 2, that is a simple question. It says, let me highlight this. Now it says find the coordinates of the points of intersection. It's a plural, points of intersection of the curve and the line. So now this is a non-linear equation. This is a linear equation. So now we have a linear equation. We have a non-linear equation. What is the strategy? The strategy is pretty simple, and that is from the linear, make a substitution and go towards the non-linear. It's your choice whether you make x the subject or y the subject. That is perfectly your choice. So now first of all, I'm making 2x the subject. I'm not making x the subject, I'm making 2x the subject, and you will soon know why is this so. And then that's the non-linear equation. 2xy plus 5y square is 24. And then in place of this thing, now let me highlight it. So now over here, 2x was made the subject. That's a very thin highlighter. 2x is -y, -4. So now this 2x is becoming -y, -4, -y, -4. And then you expand and it's the same old story. So that is about middle term factorization. And we get two values of y. One is +3, one is -2. But 2x is equals to -4, -y. So now when y is equals to 3, x is negative 7 over 2. That is x coordinate and y coordinate. Similarly, when y is negative 2, x comes out to be negative 1. So negative 1, negative 2, that is the other point. They are not asking us to solve a pair of simultaneous equations. They are asking for points of intersection. They are asking for coordinates. So make sure you write it as coordinates. For example, if you leave it as it is, at least 1 mark will be deducted. Why? Because you have not followed the instruction. So 2 questions are done. Now we are moving to the third question, that is about binomial. The coefficient of x7 in this expansion is this thing. So now there is an x term over here, there is an x term over here, the power is 5. So when there is an x term at the beginning and at the end, the first term and the last term, technically it's a binomial. So there are only 2 terms over there. So we have to apply the 3-step method. So now when we apply the 3-step method, why do we apply it? We apply it because we are unsure about the position of the term. There are 6 terms. Yes, there is one strategy. Just find all the 6 terms and you will find the relevant one. But what if the power was 15 instead of 5? Then you are stuck. So now this 3-step method is always there. What is the first one? Use a particular term formula, NCR. Second term raised to power of r, first term raised to power of n minus r. Now the first term is px square, that's raised to power of 5 minus r. Second term is 4 over px, that is raised to power of r. What is the next step? That is gather powers of x and equate it to power of required term. So this is 2 multiplying with 5 minus r. This is 1 multiplying with r. Just gather it and equate it to power of 7. Why? Because that is the power of the required term. You will get a value of r. R could come out to be a positive integer. R could come out to be 0. It cannot come out to be a fraction. It cannot come out to be negative. So now then place the value of r where it belongs. That is in the particular term formula. Simplify. And this 10p square and this 64, that is the coefficient of x7, and we can double check, yes, it's x7. So the coefficient of x7 is this thing. Simplify it, equate it to 1280, p comes out to be half. Mistakes, all the terms do not realize that this is the 3-step method. These are the common mistakes that people make. Now question number 4. It says a point P is moving along the curve with this particular equation in such a way that the x coordinate of P is increasing at a constant rate of 5 units per second. So this is dx by dt, and by the way, this is a question of differentiation, rates of change. And it says it's increasing at this constant rate. So if it's increasing at this constant rate, that means dx by dt is positive. Constant rate, and let me just highlight it, constant rate of 5 units per second, and it's increasing, therefore dx by dt is positive 5. Now it's asking us find what? We have to find the rate at which y coordinate of P is changing. If it's positive, it's increasing. If it's negative, it's decreasing. When x is equals to 9, give your answer in terms of the constant a. That is the first part. Now that is the game that we play, that y is dependent upon x, x is dependent upon t. In other words, y is dependent upon t. So first of all, you differentiate. Of course, it will be in terms of x. The second thing is that you plug in the value of x is equals to 9, simplify as much as possible, and this is what you're getting. Dx by dt is 5 units per second. And then you apply this thing. And no need to expand, just leave it as it is. Okay, so that is all good. Increasing, positive sign, decreasing, negative sign. Now the second part is also there. What is the second part? Given that the curve has a minimum point when x is 1/4, find the value of a. So for a stationary point, whether it's a maximum, whether it's a minimum, dy by dx equals to 0. Plug in x is equals to 1/4 in dy by dx. Simplify, equal it to 0, we find the value of a, that comes out to be 16. So this is like 3 marks and 2 marks, pretty basic. Question number 5. Now this is about trigonometry. The equation of a curve is this much. X lies between 0 and 2 pi. That's the same thing as saying between 0 and 360 degrees. So 4 cos 2x 2x will alter the number of cycle, 2 cycles in 360 or 2 pi radians. But first of all, they're asking for the greatest and least possible value. So now we know that the least possible value is -1, the greatest possible value is +1. Just plug in place of cos 2x. So 4 into 1 plus 3 is 7, 4 into -1 plus 3 is -1. In other words, they could have asked us the range of this y. So we would say y lies between two values. It should be lesser than or equal to 7 and greater than or equal to -1. So that's how they can ask us for the range also. Now the next thing, it says cos 2x, 2 cycles in 360, that we know. Sketch the curve. So now I have done it in steps. I believe in steps. I believe in showing all the working. So there are 2 cycles in 360. 4 cos 2x, that is the red one. This is 1 cycle up till here. That is the other cycle. Maximum is 4, minimum is -4. That is 4 cos 2x. Then we are increasing it by 3 units. So 4 becomes 7. -4 becomes -1. So basically, what the examiner is trying to do is to give you a hint so that you stay within the limits. You stay between these two maximum and minimum value. So all good, all clear. So now this green one is the final answer. It's your choice to draw it in steps. It's your choice to draw a final one. Now it says, hence, determine the number of solution of this equation. Now 4 cos 2x plus 3, isn't that y which you have already drawn? So now this is related with graphical solution of equation. The knowledge is related with this. And y equals to 2x minus 1. So draw the line y is equals to 2x minus 1. I think 2 points are more than enough. It's better that you take a 3 point also. When x is 0, y is -1. When x is 0, y is -1. When x is pi, so I'm choosing this point. When x is pi, we are getting this value. That is in decimals 5.3 something. So just draw it realistically. This is 4, this is 5, this is 6, this is 7. So between 4 and 5, label it somewhere over here. Draw a line. We are not asking, they are not asking us for the real number of solutions. Actually, they are asking us for the number of solutions. They are not asking for the solution itself because we are not drawing it on grid. How many points of intersection between this thing is there? That is these two lines, and I think by mistake I have labeled this one a little bit wrongly. So now let me just write this thing, and I hope, how can I get this thing? So now let me go, no, it's just erasing it all, and I think that has done the job. So now over here, there are 3 points of intersection. That is this one, that is one between green and blue. That is the other one, that is the third one. So there are 3 points of intersection. Therefore, there are 3 solutions of equation. So number of solutions is number of points of intersection between line and curve. That is what they're asking. So now this is all good. Question number 6. So it looks like either a area under graph question or a question related with volume. So now let me add a page so you can see the diagram more clearly, and let me just shift the page like this. Okay, so now over here, that is the original question, and it says the diagram shows the curve with this equation and the line with this equation. So there is a line and this one is the curve. The line and the curve intersected at point P, which has y coordinate 3. So if I have the y coordinate 3, I can find the corresponding x coordinate. Simple. Find the area of the shaded region. So now you have to divide this thing. You have to realize this fact that from here all the way till here, that is area under the curve. And then you have to realize that from here all the way here, that is area under the line, or it's a triangle. So these are 2 separate areas. It's not one single area. So now let's look at the working that is right over here. First of all, that is this thing. Step 1. The y coordinate of P is 3. Let's find the corresponding x coordinate. I could use the equation. I can use the line. Choose the easy option. That is finding x is equals to 1. So the x coordinate is 1. Step 2, area under the curve. So area under the curve is integration between the limits 0 and 1. So this is 0, this is 1, area under the curve. So now that is integration using chain rule. Increase the power by 1, divide by the new power. Don't forget to divide by coefficient of x. First simplify, then plug in the limits. And then you get this answer, leave it in fractions. Now, what's the next one? Step 3, that's area under the line. This is 1, this is 2. The base is 1 unit, height is 3 units. No need of integration. So area of triangle, half into base into height, that is this much. Area of shaded region is area under the curve, area under the line. Simply add it up, leave the answer in fractions. So now this thing is done. Next one, that is a trigonometry question. The first part is about proving identity. So we know that tangent is sine over cos. We know that sine squared plus cos squared equals to 1. If you want, there is no compulsion. If you want, you can write sine theta and replace it with S. You can write cos theta, replace it with C. That's your choice. So now tangent theta plus 7, tan square theta minus 3 should become this. Very little bit non-traditional. I would start from the left hand side. First of all, I would write it in such a way that there is a division sign in the middle. So this division sign right over here, that is replaced with this division sign. Now let's focus on the numerator. Tangent is written as sine over cos. So there is this sine over here. There is this sine square over here in place of tan square, and then there is cos over here. There is cos square over here. And then let's see how the simplification is taking place. It's LCM on both sides. And on the left hand side, you write it, and then the division is changed to multiplication. So division over here, that is changed to multiplication over here. So now first of all, it was this green division, change it into multiplication. And then what do? You just do the simplification, and you want everything in terms of cos square at the bottom. So wherever you feel a sine square, just replace it. So I see a sine square over here, and that sine square is now replaced with 1 minus cos square. And then it's all done and dusted. So it's a pretty basic stuff. So technically there is something like LCM over here, and then that is very thick. So that is LCM over here, and over here this division becomes multiplication. So this is simplification. And then over here, the red thing, that is the use of this identity. So sine square is there. And then over here, this is using the identity. That is sine square is 1 minus cos square. So basically, these are the three major steps, and that is why 3 marks. Question number part B. Now it's asking us to solve this equation is equals to 5 over tan theta. Now, first of all, sine cos square, 1 minus cos square. This is sine cos square, 1 minus cos square. This is technically equals to this. So now what we do is that we do the replacement, and then we write that this thing over here, this sine theta, cos theta, 7 cos square theta, 1 minus 4 cos square theta, that is equals to this thing and this thing. This is the result of part 1, and then we equate it to this thing, which is 5 over tan theta. The rest is cross multiply, simplify. Again, we see middle term factorization. So middle term factorization is very, very important. And now we are getting two values, t is equals to 3, t is equals to minus 5 over 4. Now there is no limitation on tangent. Tangent goes from positive infinity and it goes till negative infinity. Tangent is positive first and third quadrant. Tangent is negative, that is second and fourth quadrant. And it's between 0 and 180. Let alpha be the basic angle for this working. Let beta be the basic angle for this working. Tan alpha is 3. Alpha is this much. Tan beta is 5 over 4. We always calculate with the positive ratio. Beta comes out to be this thing. So even though it's talking about first and third quadrant, but because we are limited with this range, we are focusing on the first quadrant only. So we are focusing on first quadrant only, and similarly we are talking about second and fourth limited by the range. We are talking about the second quadrant only. Basic working, our theta is alpha, first quadrant, theta is 180 minus alpha. Take care of the accuracy, write the final answer separately like this. So this is all done and dusted. That was trigonometry question, 4 marks for this, and I think 3 marks for the first one. Question number 8. Now this is a circle question. A lot of people, they are very afraid of circle. I think because they tend not to draw diagrams, or if the diagram is given, they are not thinking about the diagram. So now it says, first of all, what are they saying? They are saying, let me highlight it. So now it says the diagram shows a circle with equations such and such. That is in the general form. And the line y is equals to -2. So now I can see this line, that is y is equals to -2. That is this line. And the circle is already drawn. Intersects the circle at 3 points, at the points A and B. Not 3 points, 2 points. That is A and B. So this line and circle meet at 2 points. The center of the circle is C. Find the coordinates of A, B and C. So now this is for 3 mark, and what we do is that you can do in any order. One thing is that you have to apply the completed square format method, and you find the coordinates of C, and then you solve these two simultaneously. You find the coordinates of A and B. Naturally, A will be the one in which the X coordinate is the smaller one. That's the smaller one, that's the bigger one. The Y coordinate is the same, which is -2. So let's get started over here. I'm plugging in y is equals to -2. So basically I'm working for this one. That is y is equals to -2, y equals to -2. Again, we are seeing middle term factorization. So middle term factorization is always there. So let me just stop it. Middle term factorization. We get two values. X comes out to be +2, x comes out to be +12. Smaller one corresponds to A, bigger one corresponds to B. The y coordinate is the same because that was already given. And then I think I've done the working over here. So that is for the second part. And basically I should have inserted this thing right over there. So let me just grab this thing. And it's going like this, and I hope it's all got all clear. So now I think I've left few things. Let me just copy this. Okay, now there is a problem with this. Sometimes it happens, so just ignore it for right now. So now basically this is extension of part A continued. It should have been done on that side. So now x square with the x, y square with the y, constant on the other side. First add, then subtract. So basically I've added on both sides. That's another strategy. Add the same thing on both sides, add the same thing on both sides. What do we add? We first add, then subtract. Square of half the coefficient of x, square of half the coefficient of x. The same thing with y. Simplify and then compare it with x minus h whole square, y minus k whole square is r square. So that gives me the center. So now the center is there, A and B is there. Now it's a game of either basic trigonometry or cosine rule. That's your choice. So this is 2, -2. This is 12, -2. The length is 10 units, the difference between 2 and 12. Now this C, the y coordinate is -4, y coordinate is -2. So therefore this height is 2 units. We are working in absolute value. And then if I am interested in this theta, so tangent of theta is 5/2. That is the opposite, that is the adjacent. Theta is 1.190 radians. They are asking in radians. But ACB is 2 theta. So ACB is 2 times this value. That is correct to 3 significant figures. So now this thing is done. 2 marks basically for this thing. This one was part of that, and I think the marks are a bit low. 3 marks for doing this simultaneous and middle term factorization, and also this thing, I think it's a little bit lesser marks. So now it says the chord AB divides the circle into 2 segments. Find the area of the larger segment. Now let's think about it. I have this whole angle, and they are asking for the largest segment. So basically, this one is the smallest segment, this one is the largest segment. So one approach is that let me find the area of this triangle, let me find the area of this sector, subtract, we find the area of this segment, from the whole circle subtract the segment, we get the other one. That's one approach. Other approach is I can find this particular angle, I can find the area of this major sector, add to it the area of the triangle. So it's your choice how you want to proceed. Let's see how I have done it. So now area of triangle half into base into height, that is 10. Area of major sector is half r square beta. What is beta? That is 2 pi minus this angle. That is 3.904 radian. So area of major sector half r square theta. That is why they have made you convert it into radian, because for circular measure we need to apply it. And we can also see for the first time that they are having a question of circular measure and circle equation combined together. So now what is r? R is this thing. R is this value. So this is 5, this is 2, 5 square is 25, 2 square is 4, 25 plus 4 is 29, so square root of 29. Area of larger segment, that is area of triangle plus area of major sector, and that gives us this answer. Now let's look at question number 9. It says the equation of a curve is such that the second derivative is given. It is given that the curve has a stationary point at -2, 19. Find an expression for dy by dx. Now the rule is y double prime, that's another way of writing second derivative, should be converted to y prime first, and then we should convert it into y. So now when we do this first step, we need that x is -2, y prime is 0 to find the first constant of integration. And over here x is -2, y is +19 to find the second constant of integration. Now once the strategy is very clear, let's look at the working. Second derivative is written, and then I integrate it. This is basic integration. First simplify, then write this thing. Dy by dx is this thing. Now first of all, let me write this thing. So dy by dx is this particular thing. Then what do? We write x is -2, derivative is 0, stationary point, you find the value of c, c comes out to be 3, and that is how they have not written an expression. So let me write it. So therefore dy by dx, not they, I have not written it. So this is 12 over x square minus 3. That is the expression for dy by dx. That's the first thing. Find the x coordinate of the other stationary point of the curve and determine the nature of this point. So now we have dy by dx. That is dy by dx, equal it to 0. You get x is -2, x is +2. Since we are already given x is -2, therefore what is the other point? The other point is x is +2. Now x is +2, they are not asking us for the y coordinate, they are simply asking us for the nature, and the second derivative is negative, therefore it's a maximum. And of course they cannot ask you for the y coordinate. Why? Because we haven't found the equation of the curve as yet. Now maybe this is the one. Yes, there it is. So now they're asking for the equation of the curve. So that is what dy by dx was given. Let me write it over here. And then we again integrate it. So now we integrate, we get another constant of integration, we simplify it, now plug in the coordinate, k comes out to be 7. So therefore the equation of the curve is this thing. That is how you get it. So now it says find the equation of normal to the curve at the point where dy by dx is -9/4. So you take dy by dx, you equate it to 9/4, you get two values, choose the one in which x is positive. Express your answer in this form, and then you apply the concept that the gradient of tangent, normal, and all these things. So now over here we have dy by dx. Let me grab a red marker. We have dy by dx, we equate it to -9/4. Therefore x comes out to be -4, x comes out to be +4. We reject it and we accept it. So this one is accepted. When x is positive 4, y comes out to be negative 8. That is the coordinate. Gradient of tangent is dy by dx. That's already given. That is already given. Therefore, gradient of tangent is negative 9 over 4. Gradient of normal is positive 4 over 9. So now we have 4 minus 8. We have positive 4 over 9. Write down the format of the equation and then simplify, because they want it in this form: px plus qy plus r. That is px plus qy plus r equals to 0. So this is done and dusted. Now let's look at question number 10. What is this about? The first, second and third term of an arithmetic progression are such, such and such respectively, where k is a non-zero constant. Find the value of k. That is the first thing. So now what do? The second minus the first term should equal third minus second. You get an equation like this. Always take common. Always take common. So 2k bracket k minus 6 is equals to 0. Write down k is 0, but we are rejecting y because it's a non-zero constant. And the only answer that we expect, that is k is equals to 6. Now when k is equals to 6, write down the three terms. And what are they asking for? They're asking for the value of k. That is done. So let me just highlight this. This thing is done up till here. Now when k is equals to 6, we are getting these three answers, and that will be used up later. Find the sum of the first 20 terms of the progression. So now what is the first term? The first term is 24. What is the second term? That is 12. What is the third term? That is 20. So now the first three terms, my bad, let me correct myself, that is 24, 36 and 48. 36 minus 24 is 12, and we are asking for 20 terms. That is over here. So now we use the term formula. We use the sum formula, sum of 20 terms. This is exact. Do not round off. So the first two questions are done. Now they are asking us the fourth and sixth terms of a geometric progression are such and such respectively. Common ratio is positive. Find the sum to infinity. Give your answer in this particular third form where a, b, c are integers. Now first of all, T4 is 36. So T4 is written as AR cube. T6 is 6, AR power 5. Now divide 1 by 2 or 2 by 1 because this has a bigger power. So R5 over R cube is R square. The A and A cancels off. So now when we take the even root of something, whether it's square root, whether it's fourth root, whether it's sixth root, so we always get a positive negative sign. We are discarding the negative, we are keeping the positive. AR power 5 is 6, A into R square into R square into R. So I have written R square as 1 over 6, R square is 1 over 6, R is 1 over root 6 is equals to 6. So now it simplifies and A comes out to be 216 root 6. R is 1 over root 6. Sum to infinity, A over 1 minus R. And look at all the simplification. This is LCM, this is division, and we leave the answer as it is. They are not making us further rationalize it. Just leave the answer as it is. So now this thing is done, and I think this looks like the last question to me. That is, express this thing in this form, the completed square form. So make sure the coefficient of x square is 1. First add, then subtract square of half the coefficient of x. And then we rewrite the first three terms as a perfect square. This thing goes over here. These two simplify and we get this. Now it says the function f and g are defined as follows. Fx is this. We are going to the left of turning point. So if I compare this with this thing, that is ax minus h whole square plus k, that is the gold standard. That is the one that we compare things with. So therefore a is positive. That means the graph has a minimum point. Minus h is 2. H is negative 2. K is negative 2. Therefore negative 2, negative 2. That's the coordinate of the turning point. Focus on the x coordinate of turning point, and over here we are going to the left of turning point. So fx is already known, and the next thing gx is given. Now we are starting with b, the first part. Find an expression for f inverse. We write the traditional stuff. Let y is equals to fx, f inverse y is equals to x. Then we replace fx with y. We are using this format definitely. Completed square form is the only way in which I can make x the subject. I make x the subject, but what is x? F inverse y. So f inverse y, you see all these two negatives, therefore f inverse x is like this. That is pretty basic for 3 marks. So sometimes they give you more marks for an easy question, sometimes lesser for a difficult one. Find an expression for gf, the whole thing inverse. Now first of all, gx is given, we are given fx, and first let me find gfx. What does gfx means? That means fx should go in place of x. gfx, composite function. So that is negative x, negative 4, negative fx, negative 4. And let me highlight this a little bit. So this x over here, so this x over here, let me correct it, and that is replaced with this fx. That is replaced with this fx. This whole thing is fx. Got the idea? And then you simplify, so you find gfx, that is over here. So let me write over here, that is gfx, that is up till here. Now it's kind of lame that they are asking to find the inverse once again. Maybe someone is too obsessed with all these negative signs. So now let y is equals to gfx, the whole thing. Therefore gf inverse y is x. So y is there, and then we make this the subject, and then why are we applying a negative sign to the square root? Because when we go to the left of turning point, so the square root will have a negative sign. When we go to the right of turning point, the square root will have a positive sign. Since it's a composite function, so therefore we choose the common domain. That is why we are choosing the negative sign. So that is why we choose this negative sign over here. No, not this one, this negative sign with the square root, this negative sign, this negative sign, this negative sign, and also over here we chose this negative sign, this negative sign, this negative sign, this negative sign. So therefore there were two negatives, and then we make x the subject. X is already equals to f inverse y, and we write everything in terms of x. And yes, this is the variant 1-2, just to give you an exam overview. So out of 75 marks, the A was on 61, which is pretty high. B was on 52, 40, and so on. So now this thing is done and dusted. So now we have solved May, June 2025, variant 1-2. That is done and dusted. The other variants, their videos are already available on YouTube on my channel, Mathematics with Shahab Yaqub. Take care, everyone.